Okay, so today we are going to be looking at number 13 of the week 2 math packet. Number 13 actually has 3 different problems within it. It asks you to think about the most efficient strategy for each problem. When it says the word efficient, that means the most quick way that you can think of to solve the problem while still being able to show your work and get it correct. So for some of these, drawing a picture might not be the most efficient way. Sometimes it might be using the box method to multiply. But we'll go through each problem and we will find the most efficient way. So A says, Conrad is cleaning his room. His bookcase has 7 shelves. He put 18 books on each shelf. How many books did Conrad put away? So one thing that I use a lot in my classroom is the cubes method. So we have C, U, B, E, S. It kind of helps me remember the different steps that I have to use when I solve a word problem. So, Conrad is cleaning his room. His bookcase has 7 shelves. So I'm going to circle the important numbers and labels. That's what C stands for, is circle. So I have 7 shelves, and he put 18 books on each shelf. How many books did Conrad put away? The U stands for underlining. That means that we are wanting to underline the question that's being asked. So, how many books did Conrad put away? Next, we are wanting to box the operation clues. This helps us understand what operation we need to do. Do we need to add, subtract, multiply, or divide? So, to me, on each is a really big indicator of multiplication. So now that I have boxed my operation clues and I'm telling myself that I think this is multiplication, now we are going to go through with our E and we're going to explain what we need to do to solve the problem. So first, I know that I have 7 shelves. To me, it doesn't really make sense to draw 7 shelves and then have to draw 18 books on each shelf. But in my head, I know that if I do 18 times 7, I'll get the same answer, and it's a much more efficient way to solve it than having to draw a picture of, 70, at least 70 different books. It takes so long, and you can do it a lot easier this way. So S is my final step. I'm going to solve. So 18 times 7. One way that I like to solve math problems is especially multiplication, is to break it apart into the box method. So I have 7 over here. That's how many bookshelves I have. And I have 18. If I just write 18 up here, it doesn't really help me solve it. It doesn't break it apart into any more friendly numbers. But I know that I can break 18 into 10 and 8, because I know that 7 times 10 is a lot easier to solve than 7 times 18. So now I have 7 times 10 and then 7 times 8. So we're going to take my 7 times 10, and that gives us 70. Then I'm going to do 7 times 8, and that gives me 56. Now my final step, I can't just leave it at 70 and 56. I have to add them together, because just like we separated that 18, now we have to put it back together. So 70 plus 56, 6 plus 0 is 6, 7 plus 5 is 12. My answer isn't just 126. We have to look for that label. So if we go back to what we circled, it says his bookcase has 7 shelves. But we're not looking for how many shelves Conrad put away. We're looking for how many books, because it says he put 18 books on each shelf. So we're going to add in our label, and of course we always circle it. So our answer is 126 books. Now I know that the box method is a little bit more complicated for a lot of parents to look at, because we're just not used to breaking the number apart. basically all that the kids are doing is separating that 18. So where you and I would solve it 18 times 7 just using the standard algorithm, 8 times 7 is 56, carry the 5, 7 times 1 is 7, plus 5 is 12. You still get the same answer. It's just kind of showing them how they're getting that answer. Okay, let's move on to part B. It says Conrad's dresser has 6 drawers. He put 13 pieces of clothing in each drawer. How many pieces of clothing did he put away? So once again, I'm going to write my cubes to kind of remind me of the steps I need to follow before I can solve a word problem. So C stands for circling the important numbers in the problem. So Conrad has 6 drawers. He put 13 pieces of clothing in each number. In each drawer. How many pieces of clothing did he put away? So now that I have circled my important numbers, I'm going to move on to underlining. And we're underlining the question. How many pieces of clothing did he put away? The biggest indicator for me is that question mark there. That really helps me know that that is what the question is wanting an answer to. Let's go on to B, where we are boxing the operation clues. Once again, we see this phrase in each. In each tells me that we are going to be multiplying. And then we're going to go to the explain. So explain, how are we going to solve this? I can't, off the top of my head, I don't know what 6 times 13 is. I don't have that stored in my mental math drawer. I don't understand, or I don't have it memorized. So what we're going to do is do something similar that we did up here. I'm not going to draw a picture because I don't want to sit and draw 13 pieces of clothing in 6 different drawers and then have to count them up one by one. That's not an efficient strategy. It's not a quick way to solve this problem. So I'm going to solve it like we did this part A. I have 6 drawers and I have 13 pieces of clothing in each. Now, like I said before, I don't have 6 times 13 memorized, but I do know that I could break that 13 apart into 10 plus 3. So now that leaves me to do my box method. I'm going to have 6 on the left side there, 10 on the top, because remember we broke that 13 apart to 10 and 3. Now the biggest mistake that I see a lot of students making daily is they're just breaking that 13 apart into 1 and 3. They're writing a 1 over here. That's wrong because you're basically doing 6 times 4 and you're going to get the incorrect answer. We want to do 6 times 10 and then 6 times 3. So we have 6 times 10 and we know that that's 60. And then 6 times 3 and that gives us 18. Now we can't just leave our answer at 60 and 18. We have to still add it up and put them back together because remember, we broke apart that 13. So I have 60 and 18. We're going to add those together to get our final answer. 0 plus 8 is 8. 6 plus 1 is 7. So my answer is 78, but now we have to go back and look for the label, which means we go back to look at that C section, the circled numbers. So it says that he has 6 drawers, but we don't want to know how many drawers he put away. We wanted to know how many pieces of clothing he put away. So my label is going to be 78 pieces of clothing. Okay. Let's move on to part C. Conrad has 11 containers for his toys. He put 17 toys in each container. How many toys did he put away? So once again, I'm going to write cubes down here because it helps me remember the different information that I need to find so that I can solve. So C, that tells me that I need to circle. So I'm going to circle Conrad has 11 containers for his toys. I'm also going to circle the 17 because it says he put 17 toys in each container. So now I need to underline the question. I'm going to move on to U. How many toys did he put away? I know that this is my question because I see this question mark right there at the end. B, I need to box the operation clues. Once again, we are seeing that phrase in each. In each tells us that we need to multiply or times our key numbers so that we can come up with an answer. E, we need to explain how we're going to find our answer. Once again, I'm not going to draw a picture to help me solve this because it is not an efficient way to draw 11 containers and then have to put 17 little dots to represent the toys in each. It would take way too long to have to go through and draw it and then have to go through and count it all up. Not an efficient way. So we're going to solve it using the box method like we did up above. So I have 11 times 17. The only difference with this one is A and B were 2-digit by 1-digit. Now we're going to do 2-digit by 2-digit multiplication. So it gets a little bit more tricky. You just have to be more organized in how you show your work. Let's look at how we can split up these numbers. 11 can be split up into 10 and 1. 17 can be split up into 10 and 7. Whenever I can, I always want to have at least one of my numbers be a multiple of 10 or maybe even a multiple of 5 if you can. It just makes it a lot easier because we know our 5 facts and we know our 10 facts really well. So now let's draw our box. I'm going to have 4 sections because I have 1, 2, 3, 4 numbers. On the side, I'm going to put 10 and 1. And then on the top, I'm going to do 10 and 7. This first box, I'm going to take 10 times 10 because we're going to take the number to the left and down. 10 times 10 is 100. That was an easy one. Now we're going to go down to this box down here. We're going to do 10 times 1. This 1 comes from there, and the 10 comes from there. 10 times 1 is 10. Now we're going to move over to this top right box. We're going to do 10 times 7. 10 times 7 is 70. We're getting our 10 from over here, it's coming over, and my 7 is coming down. And now my last box, which is 7 times 1. My 1 is coming across, and my 7 is coming down to give us 7. Now I can't just leave it as this. You are showing all the work, but this isn't an answer. So now we have to take all 4 numbers that we've gotten, which are 100, 70, 10, and 7, and we're going to add all of those up. 0 plus 0 plus 0 plus 7 is 7. 0 plus 7 plus 1 is 8. And 1 plus nothing in that column is 1. Now, once again, I'm not done. I have 187, but I am forgetting my label. So let's go back to my question. How many toys did he put away? So my answer would be 187 toys. And of course, we are circling our answer so that we know that we are finished with the problem. I forgot to circle that one up there. Always go through and recheck and make sure that you did all of the steps to cubes because it's really easy to forget to circle or underline, and then that can mess up your whole problem. So thank you for watching and keep posted for any future videos. Thank you.